Let's verify whether the given set, the set of integers z, is a group under the given binary operation defined as a star b is equal to the absolute value of a minus b. Here we are given that the operation is already a binary operation. So we're not going to check for this video if the star operation is closed under the given set. We'll have probably separate videos for that. We're just going to focus here on the determination whether the three conditions for a certain set to be a group under a certain star operation or binary operation is true or not. So the first condition is G1, and that condition should be star is associative in our set of integers. If we could establish this, we'll be proceeding to G2, and G2 is actually the existence of an identity element. Then our G3 is the existence of an inverse element for each of the elements on our given set. So let's work on this step by step, because if this first condition will not hold, there's no need for us to proceed to G2 and G3. We can automatically declare that the given set under the given operation is not a group. So to show associativity, let there be three different elements of our set Z, because we need to show that A star B star C is equal to A star B star C. Okay, the usual property for associativity. But of course, this will be subjected with the given operation. So let's start with the left-hand side. A star B is given as the absolute value of A minus B. But this entire expression will still be subjected to star operation together with the third element C. This will be treated as 1. So we're going to let it as our new first element, or first element on our set. And B here would be our C. This would mean we will have here the absolute value of their difference. And their difference is the absolute value of A minus B minus C. Okay? Or let me rewrite it to make it better. Okay, let's have the absolute value of A minus B, then minus C. So we have an absolute value inside an absolute value. So this is for the left hand side. For the right hand side, you have A star B star C. Okay, so we'll start with this. You will have B minus C, but this will be subjected to or with A. But A would be our first element. So A star, the absolute value of B minus C. So with this, after applying our operation, you have here the absolute value of their difference, A, minus, treating this expression as 1, absolute value of B minus C. So this is how the two forms differ from one another. Now, there might be instances where this will be true, because our set Z has infinitely many elements, and even if you're going to use 0, if A is 0, if B is 0, C is 0, both of the expressions would be 0, because 0 minus 0, absolute value of that, etc., etc. But we're talking here about all elements of A, B, and C part of the set Z. Okay? So this is not true all the time. Now here's the discussion. Of course, PEMDAS will allow us to work on this first, and the other side will be working on this first. And take note that we have here the operation of subtraction right after that. Even if we're taking the positive value of the difference of A and B here and B and C here, it will be subjected to a certain operation, subtraction. And we know that for subtraction, associative doesn't work all of the time. Okay? This would mean that they are not equal to one another. Let me have another clear example here. If this is 5, B is, let's say, 2, and C is equal to 1. Okay? So again, it will work if all the values for A, B, and C are 0. But if it's 5, 2, and 1, you will have here the absolute value of 5 minus 2, then minus 1 here. You will have that's absolute value, that's 3 minus 1, right? and you will have here absolute value of 2 here. Okay, that's correct. Okay. On the other side, you can also have the same result actually. Okay, you will have 5 minus the absolute value of 2 minus 1. That's actually absolute value of 5 minus a 3, which is equal to 2. So aside from 0, 0, 0, you have 5, 2, 1, which also satisfy the given. However, again, we have a lot of values for A, B, and C. So it's not all the time, because if we're going to interchange it, let's say this is 1, 2, and let's say this is 10. Okay, that will be the case. Let's have here the expression. What will happen here? Let me erase all of this here. Let's see if my example is correct. Okay, so for the left hand side, you have 1 minus 2. Okay, then minus 10 here. So the other side, you have 1 minus 2 minus 10. Okay, so you have here negative 1 minus 10. Am I right? Oh, no, sorry, absolute value. Absolute value. Okay. So absolute value of negative 1 is 1, and then minus 10. You have that. Okay. So you have here absolute value of, sorry, or this. Again, 1 minus 2 is negative 1. Absolute value of that is, yeah, that's correct, 1 minus 10. So absolute value of negative 9, you will get here positive 9. But on the other side, you have 1 minus the absolute value of this, absolute value of negative 8. So you have 1, that's 1. 1 minus positive 8, that's negative 7. Absolute value of negative 7 is 7. See? We have different results if we are going to consider different operations now. Different numbers rather, A, B, and C. This shows, okay, that star is not associative in Z. And further, since G1 is no longer satisfied, no need to proceed to G2, no need to proceed to G3, we can now say here that, let me use some space here. Of course, I could use the space here at the bottom. Let me use black here. We can say that Z is not a group under the given star defined as A star B is equal to the absolute value of A minus B. So no need again to proceed to G2 and G3. This is for the verification of this given item. Thank you very much for watching.